SwayamPrabha. Digital India. Educated India.
Hello and welcome to Module 8, Lecture 44, Design of Low Speed Contra-Rotating Fan. In last lecture, we started discussing about application of contra-rotating concept for aero engines. So, if we understand this contra-rotating concept, that is what is being used both for compressor as well as for the turbines. This concept, that is what is having several advantages. What we realize is there are two rotors which are rotating in opposite direction. Suppose if my one rotor, that is what is rotating in clockwise direction, my next rotor or coming rotor will be rotating in counterclockwise direction. And by doing so, basically the concept what we say combination of stator and rotor, that is what we are removing. Removing in the sense we will not be having stator in between two rotors. By doing so, we are reducing the number of components required for the engine. When we are reducing number of components, we can realize that is what will be reducing the length of my engine. At the same time, reduction of number of components, that is what will be reducing the weight of my engine. Now, when we say stage, say for conventional state, it is say stator and rotor combination. For contra-rotating, two rotors they are in combination, that is what is called stage, and that is what will be giving you higher power generating capacity or higher thrust generating capacity. So, we can say per stage power output will be very large. One more advantage is we will be having two rotors rotating in opposite direction. That is what will lead to reduce the rotational speed of my wheel, and maybe that will be helpful us in sense of rotating our wheels at a transonic speed. That is also one of the benefit. We will see again by using the velocity triangle concept. So, in overall if you look at, there are many advantages which lead to attract the attention for the researchers towards the contra-rotating concept for both compressor as well as the turbines. This contra-rotating concept that has not limitation for application to aero engine only. There are many application people they found as per their expectation. Some of them say for ventilation fan, some of them they are using for the cooling purpose. There are some special purpose requirements where this contra-rotating concept that has given the more attention. Now, here in this case, since our second rotor that is what is rotating in opposite direction. So, we can say we learn when my rotor that is what is rotating, that is what is generating the suction near my leading edge. Here in this case what happens, because my rotor 2 that is what is rotating at the higher speed, that is what will be sucking the air coming out from my rotor 1, and that is what will lead to improve the performance of both rotor 1 as well as rotor 2, and that is what is a benefit for us. Okay. Now, we realize we have seen our own experimental results, that is what is showing the performance of contra-rotating fan, and what it says, like we are having wider operating range compared to our conventional stage. Wider operating range, that means my two extremes, say maximum mass flow condition and minimum mass flow condition. We also have observed to say contra-rotating concept, that is what is giving say two kind of stall, that is what is called say partial stall and full stall configuration. So, full stall configuration, that is what is equivalent to what stage configuration that has. But when we have done our design, when we have done our experimentation, that time we realize like rotor 1, that's what is acting, it is not going under stall, even though it is operating at low mass flow rate, and that's what is the benefit, and that's what is giving the wider operating range to contra rotating fan. So my stall that will remain unstalled, say my rotor 1 that will remain unstalled condition, and my rotor 2 that's what will be behaving like a conventional stage or conventional rotor configuration. So that's what is the benefit, that's what we have explored. Now recent trend towards the development of say concept, that's what is called boundary layer ingesting engine. Okay. For that we know from entry side or from my nose of my aircraft, flow that will be going all the way towards say engine, because my engines will be buried inside my fuselage, maybe on the rear side, to take the benefit of noise as well as the placement and installation. And that's what has attracted the attention, because we are moving towards wide body aircrafts. Now under that condition, my flow which will be entering inside my engine, that will be having inflow distortion because of inflow boundary layer development. Now that's what will lead to deteriorate the performance of my engine. So people, they are looking for special applications or special kind of designs where they can avoid or they can minimize the effect of this distortion. And our own experimental work, that's what has reported, says like at the entry, if we will be having the distortion, at the exit of the stage, contra rotating stage, we are nullifying the effect of this distortion. So that is what is one of the major application we can thought of. Now if we look at, this is what we were discussing in sense of our velocity triangle, and what we have found here, if you look at, this is what is say your configuration. Now this is what is for a conventional configuration what we are having. So flow, that's what will be coming out from my rotor, that will be having some swirl component, and that's what will be entering inside my stator. Now what it does, like stator, that's what will be nullifying or say maybe minimizing the effect of this swirl, and maybe at the exit of my stator I will be having say straight flow or as per the expectation for the next stage. Here in this case, my flow, that's what will be coming out in the same way, because my rotor 1, that's what is acting similar to what rotor we are having for conventional stage. But what happens, say I am having my second rotor, that's what will be rotating in opposite direction. Say this is what is my rotational direction for rotor 2. What whirl component, that's what is coming out from my rotor 1, that's what is getting added up here. And this addition, that's what is giving us benefit. So we are basically utilizing our whirl component. How we are utilizing? If you look at here, say our relative velocity component at the entry of my rotor 2, that's what will be going to increase. Okay, and that's what will lead to give you outlet as per our expectation. So the benefit, what we can say, the strong suction, that's what is happening because of rotation of rotor 2, that's what will be changing say my flow field within say gap between the rotors. Okay. Now if we look at, suppose say here in this case for conventional stage, we have seen, suppose say we are having say tip clearance between casing and the rotor blade, and we have found the three dimensionality of the flow near the tip region. What happens? That's what will be striking on my say stator. The stator, it is a stationary body, so my flow always will be striking on my stator at off design condition. Or suppose say my rotor speed or my mass flow rate, that's what I am changing, that's what will lead to change the flow striking on my stator, and that's what is limiting my operating range. What is happening here for contra rotating concept? Suppose say we are changing our rotational speed, if we are changing our mass flow rate, we are also having tip clearance flow, but because of rotation of our second wheel, okay, that's what will be reducing the effect what we are facing in sense of difficulty for say our stage configuration, and that's what is the benefit. Now there are different studies which are being reported, and that's what is of major interest. Say what need to be the gap between the stator or say stator and rotor, that is what is the conventional stage. What need to be the gap between these two contra-rotating rotors, that is also very important. Okay. We will see all this in detail. Now, this is what is one of the application what people they have explored. So, there are special application for say high speed computing facilities. Now, they are looking for say cooling. Now, what is the purpose here? If you look at, we are having two fans which are being connected in series, like both are rotating in the same direction. So, at the exit, if we look at say this is what is your case, you will be having say your flow, that is what is coming out in a different way. Suppose this is what is your case, you will be having your outlet, that is what is say in a dispersed manner. Okay. Now, when we are having this contra rotating concept, if you will look at, we will be having intense flow, that is what is coming out at the exit. Now, there are special applications where we are looking for cooling of such kind, and that is where the attraction is there. So, if you look at say this fans, you can say cooling fans, they are of few centimeter diameter, maybe at the most maybe 4 centimeter or 5 centimeter, and that is what is serving the purpose. So, just imagine how people they are thinking of adopting the technology for special requirement, for special purposes. Okay. Now, say here if you look at, this is what we are talking in sense of two rotors which are rotating in opposite direction. Okay. Say here the special things, that is what I want to explore, it is say unexplored areas. Say still we are finding the applications for this kind of configurations. What are the applications where all we can apply this kind of configuration other than aero engines, maybe other than cooling fans? Do we have other applications? Yes, that is what need to be explored. When we are talking about the dimensions, we are still say what need to be the radius ratio. Will it be low radius ratio? Will it be high radius ratio? What will happen if I am having high radius ratio? What will happen when we are using say low radius ratio? That kind of study, that is what is still to explore. Aspect ratio of the blade, that is what is one of the major attraction. We can understand people they are moving towards low aspect ratio fans, but for contra rotating, do we have such thought? That is what is applicable, that is what is unanswered till now. Load sharing between these two rotors we will be discussing today when we start with the design. So, what need to be the load distribution between two rotors? Okay. If you recall say when we are talking about say multi-stage configuration, for that we discuss say per stage pressurize what we are expecting. Here in this case, per rotor we need to find what need to be the loading, aerodynamic loading I am talking of. We can say what need to be the pressurizing capacity of one rotor, what need to be the pressurizing capacity of my second rotor, and what need to be the pressurized of per stage, full stage. That is what need to be explored. Say number of stage selection as we discussed, say if you look at say F135, where you will realize the number of stages compared to your low bypass ratio engine, they are less for compressor, and that is what is one of the major attraction. Say blade shapes, what kind of blades we will be using, whether it will be having say 3-dimensionality in the shape. If you look at, we were discussing about the Vital project, where we have seen those blades are of different kind or different shape. There they are having something that is what is attracting say attention towards the noise, pressurizing capacity. So, that is what all need to be explored. Say whether we will be using this for subsonic application, is it equally applicable for transonic application? People they are working on development of transonic rotors at this moment. So, there my flow physics or flow structure what we are discussing, how that is what is changing, it is of major attraction. Say do we use this for say fan and LP compressor application or only for fan application? Do we think of applying that for say HP compressor configuration also? Like maybe if you look at say for F135, all my rotors they are rotating in counterclockwise direction. say for LP also, for HP also. Do we really need this kind of configuration, or maybe we can think of different way? Suppose say one can think of having say high bypass ratio engine or say low bypass ratio engine, maybe retrofitting kind of thought also can be thought of. Say you can arrange some mechanism with say gearing or say gearbox or maybe epicyclic gear train, by which you will be adding one of the rotor which will be rotating in opposite direction, and will it make the sense? Yes, that also can be one of the potential thought. Okay. What need to be the axial spacing between two rotors? Yes, that is also equally important. So, you can realize we are saying by removing my stator, basically we are reducing the length of our engine, but what should be the gap between two rotors? When we say my second rotor, that is what is rotating at the high speed, that is what is giving strong suction effect. Suppose say if we are putting very nearby, it may be possible that wake that will be coming out from my rotor 1, that will be striking on rotor 2 very intensely, and that is what will be lead to increased noise. So, noise is a major issue. Then you will think of say increasing the axial spacing between two rotors. If you are increasing the spacing between these two rotors, maybe what benefit we are getting for contra rotating may not be explored. So, that kind of study also need to be there, and there is no superficial rule at this moment. Lot of experimental results they are being published in open literature, where people they are talking about all those thoughts. Okay. So, minimum gap or optimum gap, that is what is a question. Okay. For our study we have found 90% chord of my rotor 1, that need to be the spacing between these two rotors, which is giving best performance. Okay. Now, next that is what is coming in sense of say speed combination. You can realize, suppose if we consider both the rotors they are rotating at the same speed, one can say why can I not rotate my rotor 2 at the high speed? Why not for rotor 1? Why both to be rotated at the same speed? Can we think of rotating both the rotors at low speed, same speed? So, those all things that is what is need to be explored. Okay. Now, what all we are discussing at this moment, that is what is putting some of the constraints, or we can say this is what is say in sense of challenge. What it says, we are having the mechanical challenge in sense of shaft configuration. You can understand we say two rotors they need to rotate in opposite direction. Now, can you think of mechanism where you will be having two spools, and those two spools they are rotating in opposite direction? That is what is very challenging to arrange. Yeah, suppose if we consider say one of the configuration what we have seen for say European engine, where LP compressor that is what is on one spool, and if you look at say HP compressor it is on one spool. LP compressor we have realized that is what is having say different kind of configuration, and IP compressor that is what is on the third configuration, and we have realized because we are having contra rotating concept. So, LP and IP that is what will be acting like a counter rotating kind of configuration, but it is easy to say when we are making the engine, that is what is very challenging. So, you need to explore in detail how we can configure this kind of possibilities. Suppose we are talking about say industrial fans, for that we can have two different motors which we can put as a hub, and that is what will be solving our purpose. But at the same time there are many applications people they are exploring these days for electrical propulsion system, in which the motors are available which are rotating in counterclockwise direction. So, PLDC motors they are rotating in opposite direction, and that is what is serving the purpose. So, you can understand as per the need, now research and innovation need to come. Okay. Noise is a major issue, as I told. What need to be a gap between these two rotors, that is what is very challenging, and that is what is major attraction for the research these days, because we are looking for the constraints given by Akare as Vision 2020. Now, performance map for end users, as we discussed, there are number of possibilities here. Say if we are looking for our conventional performance map where we are having our speed lines, that is what is speed of 1 or say speed of my whole engine. Now, here in this case we are having say contra rotating concept. So, we need to explore what need to be the combination of speeds. So, that is what is very challenging to develop at this moment. One thing. Secondly, your pilots need to train for such kind of configurations. They need to have idea how these things are working. Then only they can operate the engine as per the expectation. Then it says, is it possible to change the axial spacing in operation? See, when we are putting these two rotors nearby, that is what is creating issue of noise, but at the same time it is increasing the pressurizing capacity. Okay. Suppose say if I am not looking for say high pressure or say I am now interested in reduction of noise, can I change the axial spacing between the rotor during operation? It is a challenge you can think of. Okay. Like people say they were using say pitch kind of rotor or rotor pitching for industrial fans even during the operation. Now, that kind of thought process it is been explored, it is under process for engine development where your fan rotor will be having say pitching moment. So, this kind of thought also in future people they need to explore. What need to be the speed selection? Yes, because we can say we are doing our design for say compressor. Now, that need to be rotated by the turbine. So, the design for this kind of contra rotating fan or compressor is challenging. At the same time, on counterpart, turbine also is equally challenging. So, we need to explore all these possibilities, and that is what is putting lot of intense research, that is what is going on for this domain. Okay. And by near future, we will be having engines which will be having this kind of configuration, and that is what is for sure, because it has so many benefits and it is meeting with the requirements what we are expecting as a vision for the future engines. Now, let us talk in sense of say design of this contra rotating fan. So, if you recall in last lecture I was discussing about my own design for contra rotating fan which I did during my doctoral study at IIT Bombay. Now, for that configuration I was having some constraints and some restraints, and based on that we have decided with the few configurations. We were expecting pressure rise of 2000 Pascal from the stage, and this are what I have decided or what I have used for my design purpose. So, for my design, as we have discussed, my rotor 1, that is what was expected to give pressure rise of 1100 Pascal, and rotor 2 is expected to give pressure rise of 900 Pascal. And what we realize, by giving higher loading of rotor 1, that is what is giving benefit in sense of overall operating range and my performance. Okay. Now, the question is, say 2000 can be divided in 800 1200 combination, maybe it can be divided into 1000 combination, 1100 900 configuration, it can be divided into 1200 800 combinations. Yes, there are many possibilities. So, later on we have developed our contra rotating fan for one of the UAV application, that is what is called Project Aerawat, and for that we have designed electrical propulsion system, that is what was based on contra rotating concept. And for that design we have explored what all can be done in sense of distribution of aerodynamic loading, and that is what it says, like when we will be having say combination of higher loading towards rotor 1, that is what is giving the benefit, but later on that is what is reducing the overall operating range. Now, in order to realize that part, for present design or say for present lecture discussion, I have modified my pressure distribution from say 1100 to 1200 and from 900 to 800. So, we will be discussing the design of contra rotating fan for rotor 1 having pressure rise of 1200 Pascal and rotor 2, that is what is having pressure rise of 800 Pascal. and for that we will be adopting say two design approaches. One, it is say fundamental approach, and second we will be exploring with free vortex concept. There are other possibilities also. With the interest of time, we will not be discussing all the methods, because it will not make much sense. If you are interested, you can do practice and you can check with what all we are discussing in sense of results and in sense of what all we are getting as output. Okay. So, for present design, we are considering 1200 and 800 Pascal respectively for rotor 1 and rotor 2, and we will be discussing the design based on free vortex and your fundamental approach. Okay. Now, in order to have this kind of configuration, very first we will be discussing about the fundamental concept. So, let us have hint what all we can do for our design purpose. Okay. Here in this case, we can say for rotor 1, when we start our design, say we will be having say mean diameter. Okay. Say we need to calculate our mean diameter. Then for mean, based on this mean diameter, we will be doing our calculation for different velocity and velocity triangles we will be developing at the mid station. Then we will be checking with the peripheral speed, axial speed, mass flow rate. Once we are doing our calculation at the mid station, then this is what will be helping us for calculating the parameters called flow angles. Then we will be calculating our say parameters called say diffusion factor, degree of reaction, de-Holler's factor. For our verification purpose, we will be calculating our camber angle, stagger angle, deviation angle. Okay. And based on that, later on what concept we are opting, say for present method we will be opting with the fundamental method. So, we will be opting how we will be calculating the parameters at other stations. So, you can understand what we will be doing. Say for my rotor 1, I am having one blade, that is what is made up of say maybe 11 sections. You can go with the 20 sections also. Okay. And for that we will be calculating all parameters at different locations. Okay. Now, in line to rotor 2, say for conventional stage, what we have discussed, we are having say rotor and stator combination, and for that what we are calculating the flow or velocity with which my flow is coming out from the rotor, that is what is say absolute velocity C2. That is what we are assuming that is going to my stator. So, in line to that, for design of contour rotating fan, listen carefully what we will be doing. We are assuming the same way the absolute velocity with which my flow, that is what is coming out from rotor 1, that will be going to rotor 2. So, you can say my exit velocity from rotor 1 is suppose say C2, and my C3, that is what is my entry velocity, entry absolute velocity, they both are same. This is what is our assumption for the design, and based on that we will be doing our calculation at the mid station. Once we will be calculating at mid station all parameters, we will be doing the calculation for different performance parameters like diffusion factor, de-Holler's factor, relative velocity ratio, all those parameters along with the angles we will be calculating at the mid station. And based on this, what concept we are opting for the design, we will be designing the whole rotor. Now, this is what is low speed application. So, you can understand my hub diameter and tip diameter for both the rotors are same, and that is what is making our life little easy. So, we will be discussing this design in detail in next lecture. Be with me. This is what is very important, what all concept we are opting for, that is what is need to be understood clearly. Thank you very much for your kind attention.